What happens when you click a link and why the cloud runs everything? You click a link, maybe youtube.com or your bank login, and within seconds, content floods your screen. But where exactly did your click go? And what is this mysterious cloud everyone talks about? It's time we demystify what really happens when you go online, and how your data takes a journey through servers, cables, and powerful data centers hidden across the world. The illusion of instant. Let's be clear, nothing about the internet is truly instant. It only feels that way. Behind every click is a complex sequence of events where your request travels thousands of miles in milliseconds. This illusion of speed is built on decades of infrastructure investments, fiber optic lines under the ocean, massive internet exchange hubs, and distributed servers working together in perfect choreography. Your device doesn't go directly to YouTube's headquarters or your bank's main office. It goes to the nearest server that's capable of fulfilling the request, thanks to something called a content delivery network, CDN. These networks are the unsung heroes of internet speed, caching content close to where it's needed to minimize load time and bandwidth congestion. Think of it like this. If everyone in New York had to get files from a server in California, the delay would be unbearable. So instead, companies use CDNs to host local versions of websites and apps. This proximity is what allows streaming, browsing, and shopping to feel instantaneous. What actually happens when you click? Let's break it down. 1. You click a link. 2. Your browser checks its DNS cache, a local list of websites and their IP addresses. If it finds nothing, it asks a DNS server. Where's youtube.com? 3. The DNS server returns the IP address. 4. Your browser sends a request to that IP, asking for the page, video, or service. 5. That request is broken into tiny packets. 6. Those packets are routed across the globe, jumping through routers, cables, and exchange points. 7. When they reach their destination, the server responds. 8. The response packets travel back to your screen, where they are reassembled into video, images, or data. Each of these packets might take a different path. Some go across fiber optic cables laid on the ocean floor, while others might pass through local networks, satellite links, or even mobile infrastructure. They're all reassembled in perfect order when they arrive. It's not just the speed that's impressive, it's the reliability. Billions of these transactions happen every second without fail, and yet, most people have no idea what's really going on behind the scenes. And all of this is governed by what's called packet switching, a system where data is broken into pieces, routed independently, and put back together. This decentralized design is what allows the internet to survive outages, reroute traffic, and stay resilient even under stress. Enter the cloud. Here's where things get more complex. That server you just contacted? It's probably not owned by the company you think. Most modern websites and apps use cloud infrastructure. That means instead of buying and maintaining their own servers, they rent computing power from companies like Amazon Web Services, AWS, Google Cloud, or Microsoft Azure. So when your request hits youtube.com, it might actually be handled by an AWS server in Virginia, a Google Cloud cache node in Frankfurt, or even a CDN server operated by Akamai, Cloudflare, or Fastly. The cloud is not a singular place. It's a distributed network of rented servers. It's elastic, scalable, and always on. That's what makes it so powerful. Companies can spin up 1,000 servers in minutes, then shut them down when demand drops. No physical infrastructure needed on their part. These cloud servers are engineered for scale. They handle thousands of requests per second. They replicate data across regions for speed and redundancy. They use load balancers to make sure you're routed to the least busy and closest server. They can auto-scale during viral spikes, like when a video hits millions of views overnight. And with cloud providers offering plug-and-play services, like machine learning models, storage buckets, and serverless computing, even small startups can access tools once reserved for tech giants. It levels the playing field but also concentrates power in fewer hands. The cloud also allows for edge computing, where data is processed closer to the user to reduce latency. This is key for real-time applications like gaming, AR/VR, and autonomous vehicles. Why this matters. Understanding how your click flows through the cloud shows you how privacy risks emerge. Your data crosses dozens of systems. Why speed depends on global infrastructure, not just your Wi-Fi. How costs scale for tech companies with cloud billing. Based on storage, bandwidth, and compute cycles, how the entire internet relies on physical machines, not magic. Cloud providers also offer tools like object storage, content replication, and AI as a service that enhance everything from photo uploads to voice recognition. If you've ever uploaded to Google Drive or streamed a song on Spotify, you've touched cloud infrastructure. Even mobile apps, like food delivery or maps, rely on cloud computing to function. When you order a pizza, your request goes to a cloud server, which communicates with a restaurant's system, updates the delivery driver's app, and sends you notifications in real time. These systems also power the APIs that let different services talk to each other. Every time you log in with Google, check your weather app, or use facial recognition, cloud-based APIs are working in the background. Real-world analogy. Let's put this in human terms. Think of it like ordering a package from Amazon. You click Buy. Amazon finds the warehouse nearest to you. It packs and ships your order through multiple distribution hubs. It arrives at your door in 2 days or less, except instead of a physical package, the internet ships you HTML, CSS, JavaScript, and video, all in real time. And instead of trucks, your data moves through glass wires, radio signals, and electricity. The cloud is like Amazon Prime for digital content. It ensures everything loads fast, scales efficiently, and rarely breaks. But that convenience has trade-offs: centralization, energy use, and privacy vulnerabilities. It's also the backbone of AI, gaming, streaming, and even cryptocurrency. Every NFT minted, every Zoom call held, every multiplayer game session, all rely on cloud infrastructure to exist and scale. The cloud isn't fluffy. The term cloud sounds light and abstract, but the reality is loud, hot, and industrial. Massive data centers consuming megawatts of electricity, cooling systems to stop server racks from overheating, industrial fans, backup diesel generators, and global fiber optic networks. These facilities are built to be disaster-resistant. Earthquake-proof floors, biometric access controls, multiple power grids, and 24/7 staff. They're less like clouds and more like fortresses of computation. In fact, some companies are even building data centers underwater, like Microsoft's Project Natick, to take advantage of natural cooling and reduce environmental impact. There's also a growing concern about the environmental impact of cloud infrastructure. The more we rely on streaming, AI, and cloud storage, the more power is consumed. And not all of it comes from clean energy. As users, we rarely see the electricity bill, but it's real. Some forward-thinking companies are experimenting with green data centers, which use solar panels, natural ventilation, and liquid cooling to reduce emissions. As digital demand grows, sustainable cloud solutions will become a major battleground. Who owns the cloud? This is the question most people never ask. Who actually owns the infrastructure you rely on? Over 70% of the internet's traffic flows through data centers owned by a handful of corporations: Amazon, Microsoft, Google, Meta, and a few content delivery giants. They don't just serve content, they shape access, speed, and even censorship policies. This creates a centralization issue. When a few companies control most of the servers, they also control the flow of information, surveillance capabilities, and cost of access. That's why debates around net neutrality, digital sovereignty, and cloud regulation are heating up. Countries are beginning to ask, should a handful of companies really control global digital infrastructure? Some governments are pushing back by building national clouds or enforcing data localization laws, requiring companies to store data within national borders. These shifts will redefine the future of the cloud. So next time you tap a link, remember, you're not floating through the internet. You're launching a coordinated global operation across cables, switches, and servers. And the cloud, it's not above you, it's beneath you, under the ocean, across continents, and in locked warehouses. You don't just browse the internet, you request it, route it, and reconstruct it, packet by packet, in real time. Every click is a journey. Every stream is a request fulfilled by machines you'll never see. Every digital experience is powered by thousands of decisions made in nanoseconds, all hidden from view. This is the digital lens, tech demystified. If you didn't fully catch how DNS works, I've got a complete video breaking it down. Links in the top left corner. Next week, we're going deeper into the guts of data centers, the hidden giants powering the digital age.